First of all, welcome everybody join the panel. Let me make sure the panelists are on the online now. So I see Luke Iberson. Yes. Professor New. Not sure. They might have a problem to unmute themselves. Patrick and Eric. I think we're
Yes.
fine.
Hi, everyone.
Good to see you all. Looking forward to the panel.
Okay. Luke, can you talk? No? Okay. So Neuro, I don't know that we have two panelists.
Yes,
probably.
we will take care of it. Thanks.
Okay. Now we can start. Hello, everyone. Welcome to the 6G for a Sustainable Future panel session. Sustainability becomes a core requirement and a feature for the future 6G wireless. Sustainability is a large-scale and a long-term challenge for our industry. It takes many decades' effort to be effective. On the other hand, sustainability development goals, or the so-called SDG defined by the United Nations, will become the grand challenges for the mankind. No doubt about this, 6G will be the key contributor to the societal impact in terms of sustainability. We have to start to act today. My name is Wen Tong, the moderator of the panel. First of all, I would like to introduce our distinguished panelists. And they are international renowned researchers and leaders from industry and academia. Let me take this opportunity to introduce them one by one. Luke Iberson has been with Vodafone since 1996 and currently leads the Vodafone Group R&D organization, responsible for all aspects of the future research, including trials of emerging and disruptive technologies, new industry partnerships, and the creation of future revenue engines through advanced technology. Luke is an active participant in industry initiatives, including 5G AA. He is the board member, the chairman of NGMN of a 5G board committee, advisory board of UK TechWorks, and the board member of several venture-backed new technology companies in which Vodafone has invested. Luke is a proud pioneer of narrowband IoT technology and currently shaping the Vodafone's thinking on 6G. Luke is a passionate supporter of innovative thinking, helping to create new opportunities for technology to change lives and society for the better. Dr. Eric Harduring is the director of the Ambient Connectivity Research Domain of Orange Labs, which investigates future access and transport networks and technology as well as related business models. Eric received his PhD degree in signal processing and telecommunications from Telecom Bretagne and the University of Rennes, one in France in 2004. Since 2004, he has been with Orange Lab, where he has conducted or supervised research on interference mitigation for mobile networks. Between 2008 and 2013, he represented Orange in the physical layer standardization group of 3GPP Run 1 Working Group 1, or for HSPA, LTE, and LTE Advanced. From 2012 to 2015, Eric led the research on wireless network in Orange Labs. Eric had a leading role in the NGMN 5G white paper as a core lead of the network on 5G requirement. Dr. Patrick Waldemar is the VP of Telenor Research Telenor Group. Patrick joined Telenor in 2002 and he is the Vice President in Telenor Research. He has more than 20 years of management experience and education with strategic management, strategic marketing, and information technology. He holds a PhD in telecommunications from NTNU and a Master of Management from Oslo Business School. He has experience from research, development in telecommunications and the oil industry, the software development and strategic management work. Over the last 8 years, Patrick has been head of Telenor's research and the next generation network technology, focusing on 5G and 6G. Previously, he has been the head of development in Canal Digital. Professor Zhisheng Liu graduated from Beijing Jiao Tong University in 1985 and joined and get his Master of Engineering and Doctor of Engineering degree from Toyohashi University of Technology in Japan in 1989 and 1992 respectively. During 1992-94, he worked for the Fujitsu Laboratory in Japan, and in 1994 he joined with Tsinghua University in Beijing, where he is now a professor at the Department of Electronic Engineering. His major interests including queuing theory and traffic engineering, wireless communication and mobile internet, vehicular communications and smart networking, and green communication and networks. Dr. Liu has been serving the IEEE Communication Society since year 2000, first as the chair of a Beijing chapter, and then as a director of an Asia Pacific Board, director of a conference publication, chair of an Emerging Technologies Committee, and the director of online contents. He has also served as the editor of IEEE Wireless Communications from 2009 to 2013 and the associate editor-in-chief of IEEE CIC journal publication in China Communications from 2012 to 2016, and currently serving editor-in-chief of IEEE Transactional Grid Communication and Networks. He received the Outstanding Young Researcher Award from National Science Foundation of China in 2009, Best Paper Award from IEEE Communication Society Asia Pacific Board in 2013, and from the Journal of Communication and International Networks in 2019. The Distinguished Technical Achievement Recognition Award from IEEE Communication Society Green Communications and Computing Technical Committee in 2018, and the Harold Sobel Award for Explanatory Service to Meetings and Conference from IEEE Communication Society in 2019. He was selected as a distinguished lecturer of IEEE Communication Society from 2012 to 2015, as well as IEEE Vehicular Communication Society from 2014 to 2018. He is a fellow of both IEEE and IEICE. Thank you all for your time to participate this panel. We have to look to presenting live.
My pleasure to be here. Thank you so much, Wen, for the invitation as always, and it's great to be joining such a distinguished panel, listening to the bios a moment ago. Although I must say, I'm not sure where on earth you found that picture of me, Wen. It must have been 15 years ago.
It's on the internet.
But I love the time travel aspect of this.
Right.
So I'm going to talk about 6G, particularly in the context of what it needs to deliver in terms of sustainability. But obviously, just in general, we're very proud to be playing a leading role in the development of some of the emerging 6G concepts through our work in standards, 3GPP, ETSI, IETF, some great academic engagement with 6GIG in the UK, Vodafone Chair in Dresden. Also part of the EU project engagement. I see 6G Flagship is one of the sponsors of this event, and I'm pleased to be on the advisory board there. And we're putting a lot of our efforts into the NGMN, Next Generation Mobile Networks Alliance, as well as a means of trying to make sure that the operator requirements are recognised, and that we see some I would say momentum around the different use cases that might drive the technology requirements. So on to sustainability. So I thought it'd be useful to set this in the context of a broader framework. So this isn't something that exists just within Vodafone. This is this environmental, social and governance framework that I think is quite a nice way to anchor what we're going to be talking about as a panel today. The first two issues there regarding planet and the environmental impact, social contract in terms of making our services available to everybody, and also to enable the digital society. I'll come on to both of those in a moment. The piece that looks a little bit more boring around governance is actually very important, because it's broadly starting to control, not to control, but to let us consider sustainability in a business context. So this is how we'll start to see some of companies, including ours, being measured in terms of the impact that it has in terms of the environment, and the way that we would measure the viability of the business opportunity around the technologies that we embrace. So this includes things like audit and risk reviews, security, integrity of financial statements. So the things that make sure that our investment in the future is from a very, very firm foundation. So just please bear that in mind as we go through the next couple of slides. This ESG thing is, I think, a very important term. So building on that, this is our purpose from a Vodafone perspective. So the big thing in the middle, of course, this is why we exist as a company. And you will see the messaging around the importance of us reaching net zero carbon becoming increasingly visible in our own communications. It's a target that we are passionate about, and it's something that we are looking for every aspect of our technology investment to help us deliver against. And this is why it's a really good opportunity to look at this in the context of 6G as well. So that first bit is really built around 3 pillars, all of which have got a little bit of a connection to sustainability as well, even though what it's really doing is embracing our social contract, which is around trust, around fairness, around leadership. So if we look at each of those very, very briefly, trust is things like making stuff customer orientated, having transparent pricing, security, making it as inclusive as possible. But that customer oriented piece is really important, because we need to make sure that what we do here with 6G is relevant to customers and ultimately has value to them. Fairness is about closing the rural divide, and I'll mention this in a moment when we talk about the inclusion for all piece. It's also around the way that network sharing and the need for lower deployment costs is going to become an increasingly important aspect of how we plan our networks. So again, when we're looking at the operational aspects of a technology such as 6G, we need to consider it in the context of how it might allow us to deploy the assets needed to support service at lower and lower costs for the benefit of these targets. So we just look as well at some of the pieces around the edge. I'm just going to move you all out of the way a second. I can't see my own slide. I'll start with this one, the digital society. So this is looking at the power of connectivity to strengthen the resilience of economies, very much focusing on the convergence between fixed and mobile networks. And this is something that I think we do need to consider in the context of the 6G requirements, especially when we start to talk about some of the brand new capabilities regarding terahertz and combined sensing and communications, because I think that only makes sense from our perspective when it's combined with fixed communications that brings high-speed fiber assets as close as possible to the point where we're having these types of services consumed. It's also focusing on the way that as an industry we would support adjacent sectors and helping them to digitalize for the benefits of becoming more sustainable. So this includes smart cities and more ecological ways of driving the transportation networks. Also includes agriculture, it includes health. So that digital society goal, I think, helps a great deal when we start to think about the 6G requirements, especially in the sustainability context. And the last one, inclusion for all, we need to make sure that everything we develop here isn't just for rich nations, that we make sure that the services that we're enabling are available to the entire population of the planet, not just to a lucky subset. I'm not sure this is something that requires a new 6G radio interface. I think it's more about making sure that we don't forget this as we start to plan our evolution. And the last one, of course, is the aim of this session in terms of the planetary impact. We've had very, very visible targets that we've communicated to the world in terms of our ambition to become zero carbon neutral by 2030. So for those of you who follow this, we're talking about scope 1 and scope 2 by 2030 being zero for Vodafone. So that's all of the energy that we buy. So it's making sure that the power that we consume is derived from sustainable sources. So it's also making sure that we eliminate the burning of carbon-powered or fossil fuels within our own operations. So, for example, where we have to use diesel generator sets today to power sites that are off-grid. So that emissions from our own use is something that we want to eliminate by 2030, which isn't very far away. By 2040, we want to halve our the scope 3 impact as well, which includes everything else. So top level importance from our perspective. So what does this mean for 6G? So I think 6G, we still don't know what 6G is going to include, by the way, and we can come on to that a little bit later in the panel. Whatever 6G turns out to be in that 2030 timeframe, we know that it has to deliver on all of those objectives that have just been running through in terms of its sustainability goals. It needs to deliver services with net zero carbon. It needs to provide fair and inclusive capabilities that build on the principles of network sharing, lowering the cost, enabling us to digitize adjacent industries. All of those things should be taken as read when we go through these points. But if we just make a few specific observations. First, around long-term viability. This is $1 billion investment for people. There has to be a path towards long-term viability, and that can only be achieved if it returns a positive return on our capital. And very, very simply speaking, this means that it must either meet a new customer need, so do something that generates a brand new line of revenue. It needs to reduce our costs, or it needs to help us take what we have already and drive the revenue associated with those services. It has to do one of those things. Ideally, it can do them all. It needs to do at least one. This is often forgotten when we start to look at the new technology. Second one is critical for sustainability. So this is around making sure that our use of what is ultimately a finite resource is as responsible as possible. So we've got constraints everywhere with this. We're constrained in spectrum, especially when it comes to wide area spectrum that's useful for delivering services in outdoor areas. EMF radiated power limits, so this needs to remain safe. We need to respect the carbon targets that we've just been talking about. We need to avoid a massive explosion in the power consumption, so we can't just keep throwing more and more power at cell sites. We also need to recognize that we can't just build new cell sites hand infinitum, because that in itself has a large carbon impact, even when you consider the concrete that's used to construct things. And last but by no means least, we need to make sure that we fulfill this social contract to talk about in terms of being inclusive, in terms of helping other industries to digitalize, which in turn helps them to become more sustainable. So I think, and I'm aware when I've nearly out of my 10 minutes, so we really believe that 6G has to be assessed against this broader economic, social governance framework that makes sure that we can build this digital society, that allows us to embrace progress and brings the very, very best that all of the community that we're addressing today can deliver, but it does it in a way that is sustainable. So I'll be quiet now, and I'll look forward to the to the Q&A session, and hopefully I haven't gone too far over my time.
Yeah, look, thank you. I think we will pick up the video again for the other panelists of pre-recorded presentation. Thank you.
Thank you.
My name is Zhisheng Niu from Tsinghua University, Beijing, China. Today, I'd like to share with you some of my thoughts on 6G and provide a new horizon for energy efficient design of 6G networks. Here by 6G, I simply means the mobile communications networks in around 2030, without any specific definition on any particular technologies. If we have to say something on it, I think it could be called mobile things or mobile society, embedded with more intelligence, rather than just a mobile phone in first generation and second generation, and the mobile internet in third generation and fourth generation. For this purpose, future 6G networks have to include more computing facilities to execute big data analytics, which may in fact consume much more energy than base stations. For example, a simple high-performance CPU and GPU may consume as much as the energy to run a 4G LTE base station, while a typical edge server may need tens of such CPU or GPU cores. On the other hand, as shown in this table, the data processing for model training or inference may cause extreme amount of CO2 emission. In addition to that, as shown in this figure, our love of the cloud is making a green energy future almost impossible. It is expected that the energy consumption of data centers in 2025 will be the top share among all the ICT sectors, almost a 10 times increase than 2015. As a result, we should not only consider the energy reduction of base stations, but also those edge servers. But as shown in this figure, the traffic demand is continuously increasing anyway. Therefore, the key question will be, can we send more information with less energy? In short, SMILE. If yes, how should we coordinate the heterogeneous base stations and also between base stations and edge servers? This is definitely not an easy task, if not impossible. To make this impossible possible, I think there are three approaches that we can take. One is energy saving by more aggressively turning off the underutilized base stations as well as edge servers to reduce the energy waste. The second approach is to incorporate more renewable energy by energy harvesting technologies. And the third approach, which is the main topic of today's talk, is to use AI on demand. In the following, I will introduce these approaches one by one. For the energy savings, the key issue when we want to turn off the underutilized base stations is how to provide the coverage guarantee. To solve this problem, we have proposed a so-called hypercellular architecture, in which the coverage for control information and the coverage for data service is decoupled, so that the coverage is always guaranteed by control base stations, while the data base stations can be switched off whenever the traffic is low. With this new architecture, the network planning as well as the network operations can be adapted to the traffic dynamics and therefore reduce the energy waste. In other words, the traffic flow and the energy flow are tangling for a harmonized adaptation. The fundamental problem are then which base station, when, and how long should sleep. We are then using queuing model to characterize the energy delay trade-off in base station sleeping control. And very surprisingly, found that the energy and the delay, in fact, is not always a trade-off. That is to say, reducing energy does not necessarily bring increased delay. Or a win-win solution is possible if the sleeping control is well designed. In addition, we also found that the optimal base station sleeping control is a two-threshold policy. That is, the work mode switching from adaptive to sleep mode or from sleep mode to active mode should be hysteretic in nature. For the second approach, that is using more renewable energy, the key challenge we need to deal with is the mismatch between energy supplies and the traffic demands. For this purpose, we have proposed a new concept called energy informatics for smart interaction between energy and information. In short, Einstein. The key idea here is to match energy flow to information flow, and vice versa, to match information flow to energy flow. For instance, if information is flowing up, we can pull more energy from battery. On the other hand, if information is flowing down, we can charge the battery. On the contrary, if today's energy is more than enough, we can cache the contents or push to users in advance, something like doing tomorrow's job today. Or if today's energy is not enough, we can just provide the basic service only, but postponing enhanced service to the future, something like doing today's job tomorrow. Or offloading to clouds, something like asking help from the others. Here, one of key challenges in energy harvesting system is how to deal with the triple dynamics in a harmonized way. That is, in addition to the dynamics in channel and the traffic demands, there also exist dynamics in energy supply. Another new challenges come from the new constraints of causality and timeliness of the available energy. As a result, considering energy efficiency only is not enough anymore. We should also try to avoid from energy outage and energy overflow. In other words, energy sustainability would be a key performance metric in energy harvesting systems. Last but definitely not the least is a new horizon that we should take into account. For sure, AI will be key enabling technologies for future 6G networks, but it will bring enormous energy consumption. The fundamental question is then, can we reduce it in a drastic way? The key idea here is AI on demand. That is to say, AI capability should be provided on demand. It is obvious that we don't need AI all the time and everywhere. In particular, we should only consider to use AI when modeling is impossible or extremely complicated. For example, when channel has nonlinear correlation, or there is unprecedented blockages. Second, when data is available enough, and most importantly, in high quality. Otherwise, AI will be useless. The third, when AI-based decision-making can be real-time. Otherwise, AI will have very limited use. And the fourth, when AI-based learning and inference is cost-effective and energy efficient. Otherwise, AI will not so helpful. In this regard, we have done some researches on network-assisted green AI for future 6G networks, including energy-efficient DNN, co-inference by splitting with pruning, mobility-enhanced vehicular edge computing and caching, and edge learning and cooperative inference with timeliness constraint. As one example, we have proposed an energy-efficient federated learning scheme where multiple heterogeneous workers with non-uniformly distributed energy supplies learn a shared machine learning model collaboratively using non-IID local data with the help of a parameter server. Simulation results have shown that data redundancy can significantly improve accuracy, but the marginal effect diminishes. In addition, dynamic scheduling policy can achieve close to optimal performance without violating the energy budget. In summary, greening 6G needs to take a holistic approach from radio access networks to computing facilities and further to AI algorithms. For sure, AI will play a key role in 6G development, but the usage of AI have to be on demand. In this regard, we believe greening AI is a new horizon for SMILE. To conclude my talk, I would expect everybody on the line to keep SMILE every day. Thank you very much for the kind attention.
Hello, my name is Eric Ardouin. I'm with Orange, where I'm in charge of the research on connectivity. So this is my introductory talk to the PIMRC panel on 6G for a sustainable future. So I have a couple of slides that I'm going to share. Okay, so as we know, 6G is the topic of a massive research effort around the globe today for a deployment which is anticipated to take place around 2030. And we are still in the early days of 6G design, so we are at the moment where we are, on the one hand, investigating technical solutions to push the envelope of what networking technologies can offer. And on the other hand, we are also imagining what kind of new services we will be able to provide with those enhanced capabilities. And as we all know, sustainability is one of the mainstays of our times, and it will be also the case in the 2030 to 2040 decade when 6G will be deployed and operating. So one of the very important questions that we need to ask ourselves today in those early days of 6G design is how can we shape 6G to allow the future society to be more sustainable? And for that, there are two important aspects that we need to consider. The first one is how we can build 6G to improve the future sustainability of the society. And for that, there is a need to identify the services that will be needed by the different sectors of the society in the future, whether it is industry, agriculture, or cities, or administrations. And the goal here is to identify how we can help those sectors in their activity to reduce, for instance, their greenhouse gas emissions. And for that, the best way is, of course, that we have a tight collaboration with those future users of the technology to understand their needs, and also to derive from that how we need to make the technology evolve, what kind of technical requirements we need to deliver, and also, of course, what are the solutions that we need to invent to respond to those requirements. And that's from the perspective of sustainability, but of course, those services, they will need to be also relevant from an economic perspective. So not too costly to deliver, and also providing sufficient value so that there is a market and the consumers willing to pay for that. And of course, they will need also to be feasible, so they will need to require capabilities that we will be able to deliver from the technology perspective. But still, the most important thing we need to do at the moment is to have this dialogue with the future users, to have a clear understanding about what are their own needs and what are the needs they foresee for the 6G era. The second aspect that we need to take into account is the sustainability of our own technology. So the sustainability of 6G, which can be addressed from various perspectives. We have taken into account the need to be energy efficient from the design of 5G, and we have achieved some success with that, but of course it's something that we need to continue and further amplify with 6G. And we need also to take into account the other environmental impacts of mobile technology. For instance, the energy and green gas emissions associated with the manufacturing of the different equipments, the network equipments, and also the user terminals. There are other different societal stakes associated with future technologies that we have summarized in this diagram you can see on the screen, and that we have called societal requirements. And we, at the same time that we need to make sure the technology will be sustainable, we need also to ensure that it will also be resilient against the possible future climate effects like floods, hot waves, and so on. So that also put constraints on the way we will design the technology. And in terms of research challenges, we need to define indicators to be able to evaluate how the design of 6G will match with those important societal stakes. And also we will need tools to be able to evaluate how much of those indicators we can achieve. And of course, eventually we need technical solutions allowing us to improve the technology in the directions which are needed to achieve those societal requirements. So that's it for this very brief introduction. And now I look forward to the panel to have more discussion on this very important topic. Thank you very much.
Good afternoon, ladies and gentlemen. My name is Patrick Waldemar, and I'm a Vice President in Telenor Research. In my daily work, I head up the research on next-generation technologies in Telenor Group. I'm happy to be part of this panel at PIM-RC 2021 and to be given the opportunity to express my views on 6G for a sustainable future, including my thoughts on what's missing today. But first, let me tell you a little bit more about the Telenor Group. Telenor was founded in 1855, and in its 166 years, Telenor has evolved from a Norwegian telecom incumbent to an international mobile operator in 8 markets with 170 million subscribers. Telenor's operations are in the Nordics in 4 markets and in Asia in 4 markets. This is excluding Telenor Myanmar due to the ongoing sales process. Telenor Research was founded in 1967 and has contributed to numerous innovations over the last 50+ years. Some examples are the establishment of satellite networks in the 1970s and contribution to GSM and MPEG video standards in the 1980s. Development of the Opera browser in the 1990s, and use of mobile data to improve prediction of dengue fever in 2013. Since 2012, we have had research on 5G with focus on network virtualization and RAN developments, and over the last years, we have started working on 6G. The role of research in Telenor is to help Telenor Group and BUs in various aspects. In order to look into 6G for a sustainable future, let's start with defining where we are today. What is the 5G shift really about? Well, we have seen the development from 1G to 4G, going from analog voice to mobile broadband. And when it comes to the 5G shift, this is really about providing communications to industry verticals. We have just started the 5G journey, and through release 15 to 17, we will see improvements in performance, functionality, and features. When looking towards 6G, sustainability should drive the evolution. So, what do we envision beyond 5G and towards 6G for a sustainable future? What learnings will we get from our current 5G rollouts? And what new challenges would we like to find new solutions for? Which consumer trends will define future communication needs? And what role will industrial communication and focus on a more sustainable world play? Now, I would like to present my views on what's missing today in order to create a 6G for a sustainable future. I will do this by looking into 6G visions, challenges, and research directions. In my view, the most important 6G visions to enable a sustainable future are a sustainable resource usage. This is about energy consumption, material usage, recyclability, and operational efficiency through full autonomy. Second, it's about empowering the society through targeting society industry with communication solutions and addressing the global digital divide. And third, it's about standardization and industry collaboration and accelerating innovation through open source and open interfaces. There are several key challenges that we need to look more into in the coming years. First of all, we need to support and contribute to the 17 UN Sustainability Goal. We need to ensure security and trust in our solutions. And our systems need to be flexible and automated. We need super flexibility. In order to deliver on the 6G vision and contribute to the challenges, I would like to point at the following research directions. Research on enabling technologies like spectrum and spectrum efficiency, the use of terahertz frequencies, AI in networks, and looking more into cloud-native architectures. As a second item, we need to look into the consumers and verticals. 6G should be designed to enhance the support to industry verticals, as well as supporting new consumer needs. And third, we need to look more into 6G ecosystems. More research is needed in order to understand future roles, partnering options, and the societal impact of future 6G services. So, in summary, my key messages for a sustainable future are the following. We need a 6G vision with focus on resource uses, empowering society, and open innovation. We need to challenge ourselves with regard to supporting the UN Sustainability and Development Goals. We need to look more into security and trust in our solutions, and we need flexibility in our systems. To support this, research is needed on enabling technologies, consumer and vertical industry needs, and on 6G ecosystems. So, Thank you for watching my presentation on 6G for a sustainable future, including my thoughts on what's missing today. I'm looking forward to answering questions in the upcoming panel discussion. Thank you very much.
Okay, thank you, Patrick. Now we finished the presentation part. Let's get into the question and answer. I think I have 4 questions. What I would like to do is we do a roundtable on these 4 questions for the panelists, and then we'll open up for more general question and take the question from the audience. So the question actually was on the program. I tried to type it here on the chart. So basically, the first question is these are structured questions. So the first question is, what are the requirements and the new dimension for sustainability while we develop the 6G mobile communication system? And the follow-up is, what is the potential new performance indicator to reflect this sustainable design requirement, and how to develop the methodology to evaluate them? So that's the basically regarding the sustainability in terms of how to evaluate and how to quantify them. I will let me go through the the round robin for the panelists. So Luke, are you okay to take the first step?
Yeah, I can kick it off. I think we've just had some fantastic perspectives from the rest of the panel anyway, which I think addresses the broad question here in terms of the requirements. And it was good to see, I think, such a lot of alignments between people in terms of recognizing the importance of those goals. I think it's more interesting to consider what these new performance indicators might be. And clearly we need something that reflects the energy per byte per kilometer squared. So when we look at the aggregation of the goals around sustainability, we need to have some hard metrics to help us explore what makes sense there. The other thing that comes to mind when I look at that question is, again, there's the context of the mobile and the fixed network, because when we look at what we need to do to deliver that type of capability across an area, we need to recognize that a lot of these services, especially the ones that demand very, very high data rates, are indoors to static users. So it's not going to be energy efficient to try and serve those users by having a giant beamforming array outside a building trying to blast its way through the windows and through the concrete. It's more efficient to have a very, very high performance fiber into the building and have something indoors that's serving that particular requirement. So I think as we look at those performance indicators for sustainable design, we always need to reflect or consider the environment and the circumstances in which some of these services will be consumed, and make sure that the way that we measure the system energy consumption is reflected in how those services will be delivered. So that's just some initial thoughts.
Okay, thank you. Patrick?
Sure, I can have a go. I think, I agree, it's very good to hear the good alignment in the presentations. And I do, if I were to pull on one thing, it is how we are going to control our energy usage. And of course, at the same time, deliver on what is needed. So if I then move on more to the KPI part, I think, it's still relevant with looking at traditional KPIs like energy per bits and so on. But we need to, it were pointed that, we're going to need more and more compute resources. So we're gonna need something that trades off between what we are actually delivering to a system versus the cost in terms of energy usage. And I think we need to put it into the system so we can do the optimizations as we try to design them. I think that'll be my first try on this one.
Thank you. Professor New?
Hello, this is Zhisheng Liu. Okay, so for this question, as I mentioned in my presentation, that I think the traditional, the dimension or the KPI, just as Patrick mentioned, we only measure the energy per beat or something like that. That definitely is not good enough. I mentioned in my presentation that the traffic demand is increasing, and that will not stop. So that means we have to have a carbon neutral, the big goal of carbon neutral. So I think the new requirement or the new dimension should be the total energy consumption of these 6G networks as a whole, not including the RAM, but also the computing part. So that means not the energy efficiency is not enough anymore. We should consider total energy consumption. We should reduce that, but not only increasing the energy efficiency. This is my thought. One more, I'm sorry. So for in particular, for example, we can set a target. For example, can we lowering down the total energy consumption by half, for example, but by the year 2030 or something like that. But we have to support the traffic demand. This is why I named it as a SMILE. Thank you.
Thanks, Eric.
Yes, yeah, I also agree with what has been said before, and in particular about the fact that if you increase the data rate and capacity, then you need to increase the energy efficiency with the same proportion. Otherwise, your overall energy consumption will increase. And energy, of course, energy consumption is a very important metric. But now, in Orange, we think that we need to go beyond just energy, in the sense that we know that networks have other impacts on the environment than just the energy. You have all the materials and all the energy to extract those materials that come into the manufacturing of the equipments, including the water needs to build those equipments, just to extract the minerals and so on. And that's the whole chain, the whole environmental impact of the supply chain that we need to take into account. And this is not easy. There are research works ongoing at the moment to try to quantify those various environmental impacts of the ICT, including in use and also for the manufacturing and end of life, including recycling and so on. But even beyond that, it's even more complex than that, because in the end, we also know that ICT technologies in general also have a positive impact on various societal aspects. Video conference like we are having today reduce a lot the CO2 emission associated with, in particular, transportation and the planes fuel, because in principle we all would have taken planes to go to the conference place, but we are saving all this fuel right now, and that means that we can afford to spend, maybe to have some environmental impact on using ICT if it allows us to save much more in other aspects of the society. And this is this whole equation of cost versus benefit that we think we need to take into account. And that's why we, as I said in my introductive talk, it's very important that we identify some services that we want the technology to offer in the future for the society in order to have some positive impact on various societal aspects. And once we have that, then we need to build the technology that will allow us to meet those objectives. Yeah, so that's it for me. But again, this whole holistic vision and the related KPIs clearly require some research because we don't have them now.
Yes, thank you, Eric. Yeah, I think what is not clear to me, in order to get some methodology to evaluate this for the communication infrastructure, and as well, the metric, it looks like a very complicated work. As Eric, as you said, for the video conferencing, there's one work, somehow it is related to some 400 and 500 parameters in order to compute a carbon emission event for the whole end-to-end system. So it's a very complex process as well. I'm not sure the research is mature as in that regard.
But if I may, Wen, I think
Yes.
Eric raised a very good point around making certain that the environmental impacts of things like constructing new cell sites is properly captured in the design, because it doesn't come for free, and there is a lot of inherent energy required to construct these things. And if we're not conscious of those things at this stage, you start to deploy a system design that satisfies the performance requirements but doesn't satisfy the overall goal to have the system deliver on those net zero carbon targets, because you've built far too much infrastructure to be able to sustain that. So I think it is a tricky one. I think we do need some more holistic indicators to help us navigate through that, so that we can assess the different technologies against that. And again, I will iterate again, we need to decide what we're trying to do in different environments. It's a massive difference between outdoor consumption of services and things indoors, or in factories, or in verticals. These are all very, very different.
Right. And there's some curves published by NASA that was like in the 6G time frame, let's say 2040. If we don't do anything, the average temperature of Earth will rise up about 2 degrees Celsius, so which is pretty alarming.
Yep.
We will see dramatic change of the
I agree.
living condition.
And this is why we've accelerated. I think many companies are doing this. We've accelerated our targets for net zero carbon. So if you look at the investment climate within companies such as ours, we would only be looking favorably on technology advances that can help us achieve those goals and not drive it in the opposite direction. And deploying massive new networks and replacing what's there is a disaster from an environmental perspective. So we need, so it sets the bars even higher on what comes next if we're going to pay attention to this. And
Right.
we will now. That will form part of our investment case, certainly. And I can't believe that other operators won't be in the same position.
Right. Okay. So let me move into the second structured question. That is, to look at if 6G can help improve the sustainability improvement, development, or protect the environment, which means that is there some 6G capabilities, the new capabilities can help the sustainability goal. I feel that Professor New in his talk has touched upon some of these aspects. I would like to go ahead with you first to get into this question, Professor Liu.
Okay, thanks. So for this potential new capability of 6G for the I mean the sustainable development, I think there may be many, as you list up here, the convergence of sensing, computing, and the integration non-terrestrial. There may be many, but I want to raise another one that you may not be able, you may not be aware. That is the broadcasting. So in order to support, for example, the next billion or the people in the rural area or in the very underdeveloped area, and we need a seamless coverage. But in order to do that, of course, the satellite may work, may help, but also I think the terrestrial broadcasting network may also help. That is the infrastructure has been there for many years, but is very underutilized. So so how can we integrate this broadcasting network together with our communication network? That is one possibility for next generation. This is because basically the broadcasting network is only one dimension, one directional. I mean single, unidirectional. They don't have the feedback channel. But by integrating the broadcasting network with the communication network, then we can have a feedback channel so that they can provide a data broadcasting service. So for that purpose, I believe the Chinese government have launched the fourth operator in China for 5G operation. As you may have known that there are 3 big operators in China that have got the license for mobile communication. That is China Mobile, China Unicom, and China Telecom. But one government released this license spectrum for 5G networks. They added another one. This is called China Broadcasting Network, CBN. That is the fourth operator. So I believe that will play a very important role in the future. So that means how can we integrate the broadcasting technology and the communication technology? Thank you.
Patrick here. I'll take the chance. You know, I really like your idea of utilizing the broadcast channel more. Then again, having spent 10 of my last 20 years in the broadcast area, you will always come in this situation of you need to be able to do a trade-off, because as you say, it's one-dimensional, it's unidirectional, so you need to figure out when are you going to distribute, store, and then make use of it, and how are you going to solve that optimization problem. And
right.
I love that problem, so I really hope that we will work more on it going forward. And but it's not a trivial problem to solve optimally, because with broadcast you take the cost up front most often, whereas with our unidirectional parts we kind of can gradually build out our networks. So that was just my comment to that one. I like that idea. And then if I'm still on, I'd like to say that, you know, one way that we can improve for society good is, of course, to understand better the society needs. And I think we have for a while now worked with 5G, focusing on solving industrial problems or creating industrial solutions, and improving those and making sure that they are more sustainable, that they are more efficient, is probably one way, if we are going to both succeed to make use of the mobile communication technology at large and to help the society. So I really see there is a need to continue to optimize the solutions that we're creating now for industrial verticals.
Thank you. Eric?
Yes, so when it comes to improving the society good, I mean, there are major areas we can think of immediately, like optimizing transportation for reducing the gas consumption, or improving health, or improving telepresence, like immersive communication to further reduce the need for physical trips. But when it comes to the detail, then it's necessary that we go and talk with people from those various sectors, and from also all the other sectors I haven't mentioned, to understand what are their needs, because only them in the end they know exactly how what they would need to improve their own environmental impact, and improve their own sustainability. So with 5G, we have started to engage a dialogue with different industry representatives, and that was a very good move. And we need to further continue it, to amplify it, but also to extend this mindset of talking with other user at large. And I think that probably should go also beyond purely industrial players, but we should also talk more with maybe societal representatives, including NGOs or United Nations or the UNESCO, which maybe are organizations we typically don't have today that many relationships with as technologists. But in the end, the main idea is that we need to talk with the future users to understand how we can help them through the communication technology to improve their own sustainability.
Very good. Luke?
Well, what can I add? I think those are all very, very good answers. I think, yeah, I think somebody mentioned, I think it might have been Patrick mentioned that the benefits of stability and optimization when it comes to actually, the detail of how we can drive down the energy consumption and make sure that we, continue to move things in the right direction. We said before that none of us are saying that what 6G actually is at this stage, and the extent to which it revolves around having to do a brand new air interface to deliver capabilities everywhere. I think we need to recognize that if we were to do that, there is a price that's paid in terms of halting the ongoing optimization of and the very fine tuning of 5G NR, for example, that allows it to provide some direct benefit to countries and industries trying to digitalize and improve their sustainability. So I think we shouldn't be considerate, and I'd agree with what Eric has just been saying around engaging with the people to whom these technologies ought to deliver some useful purpose or some useful outcome. We shouldn't be saying, you know what, fantastic that we understand what you guys need, but we're not going to give you anything until around 2030. This would be the wrong answer. I think if we look at the 6G piece more holistically, and we look at how we're evolving the tools that we have as an industry to be able to serve those adjacent opportunities, we should be doing a lot more now. So in having a 6G conversation, if it teases out how we can deliver some wins and some benefits to society in these different areas, then I think we should take that opportunity as well, and we shouldn't wait for this magical time frame of 2030 plus before we start to do that. So anything we can do to improve things now, I think is good. I guess the final point, and it mentions it there, terrestrial versus non-terrestrial. Obviously, the complementary. Again, I don't see that particularly as a 6G thing. If we were to magically provide, a network in the sky, for example, for the entire planet, you wouldn't choose a technology like 6G right now. You'd choose something like 4G and 5G, because you'd need to make it relevant to the devices that people have in their hands and that are affordable and that can get hold of. So I would look us to always consider what the real benefit is to the end user on this stuff in terms of the sustainability piece and how it can drive the investment that's needed to to bring forward some of the capabilities that we already have. 5G, and we look back at the 5G requirements that we had 10 years ago on this stuff, a lot of the capabilities are still sat on the shelf. There hasn't been a commercial use case that's come out that's allowed us to even scratch the surface of what we can do with that technology. So we need to use this dialogue with other parts of the industry to make sure that we're able to address that. That would be my thought.
Yeah, excellent. So that is related to 6G part. So the basics we have most of panelists are operator. So I guess the number 3 question is, what are the key technologies of green communication, network design, and how they advance 6G, and how to carry out end-to-end efficient design. So basically, this is I will say this is a wish list if the operator can can provide for the people working on 6G. So if from this perspective, what is your wish list, Patrick?
Thank you. I'll, first of all, I mentioned some enabling technologies in my presentation. Of course, they need to continue to be developed in the radio spectrum side and also, of course, in the core side. When we look at this in particular with the green perspective here, I think it's about full distribution of the resources, of the nodes, of the functions, so that you find a new way to do this optimization. And maybe we're back to cross-layer optimization, throwing away the OC stack or something. And in my opinion here, we are really back again to the energy of optimization and how that is done, how we utilize AI to do that. And of course, you're also in the circular economy and how we recycle things, as I briefly mentioned as well. So wish list is, of course, then that these needed enable technologies will evolve, but that we also actually understands how to utilize them in dialogue with the consumers and the industry.
Okay. Luke?
Oh, I'm wondering if, I mean, you've heard a lot about the outcomes that we're seeking as operators. I think that's been clearly articulated. We're not particularly inventing the technologies. That's for this fantastic community to come up with some solutions. Perhaps it's useful to again reiterate what it can't look like. So I think it can't just be something that requires operators to build out 10 times, 100 times, 1,000 times more cell sites. That's not the right answer. It's a traditional answer. Densification. It's not going to work. It goes completely the opposite direction in terms of sustainability, and it challenges the basic economics as well. So we can't just throw more sites at it. You can't throw more necessarily more spectrum at it, in the sense that the only new spectrum that will be available in this context is very, very high frequency, very short range. Again, that doesn't help when it comes to not just throwing more sites out there. And finally, we can't just throw more power at it either. So again, we've tended just to assume that we can power these massive digital beamforming arrays that consume very, very high amounts of power. So a great technical solution that somehow just results in us having to put more and more energy into base stations and more base stations is a non-starter. So I can't tell you what the right answer is, but I can tell you what the wrong answer looks like a little bit. I don't know if that helps. Hope so.
Very good. I guess we don't have Eric yet. Eric?
Yes. Well, as I think
What
it
is
was
your
Professor Yu.
wish list? Yeah.
Yeah, I have one. Well, as Professor New mentioned in his talk, I mean, the best way to save energy is to turn off the equipments when they are not needed. And with 5G, we have provided ways to enable turning off the base stations for extended time periods. But now we have the problem of how to or when to decide to turn off the base station and when do we need to start it again in order to serve customers. And there AI can play a role to help identifying those those instances where we need to turn off and turning back the equipments. And our wish list is a network that would consume absolutely nothing when there is no traffic. And this is something that we is clearly a research objective for us. Then, as we have mentioned, there is also all the energy which is needed to build the equipment. So the ideal network, we would not need to change the hardware. The hardware would last forever. I mean, you asked for a wish list, so I give you one. I'm not saying this is feasible, of course, but extending the use time of equipment when it makes sense is also something that would be desirable. And for the network equipments, maybe that's not the best thing to do, because we know that with each new generation of hardware, we gain a lot in terms of energy efficiency. But when it comes to terminals, maybe for some users who don't use all the latest highly data hungry services, having terminals that could last for years and years and years and years maybe would help partly to solve the CO2 emissions associated with the terminals. Also, there is one promising research area, which is the battery-less devices, and that's particularly for IoT. IoT devices transmitting a small packet once in a while. Then there are possibilities to reduce significantly the energy necessary for the transmission in such a way that they could be operated on solar panels, for instance, and so that those ones they could last forever, more or less. And that's also something that we are very interested in. And the last one is a research area which is also very promising. It's about transmitting only the relevant information when it is needed. And in particular, when there is, that's a very basic example, but imagine that you have a video camera which is transmitting all the time some video stream and to a server which is then performing some recognition to detect anomalies, for instance, or defects on an assembly line. Then it would be much more efficient to transmit only an alert to say, okay, now there is something wrong on that particular piece, instead of transmitting all the time the video stream, even when there is nothing in the end no useful information in that video stream. And that comes to the topic of what we call semantic communication, which is still in its infancy, but and it's not clear at all that it will be mature for the 6G era, but at least having a global optimization of the sensor, the network, and in the end, the application in order to transmit only the minimum information that makes sense to the end user is also a promising research direction.
Excellent. I like all these three, the list from three carriers, just because you didn't mention your wish list including zero cost of equipment. Okay. The last one is Professor Liu.
I'm not an operator, so I'm just a professor, so I may not be able to answer this question. But basically, as a user of the network, in fact, what we are expecting, in fact, is not seamless coverage. It's also not the massive. I mean, the broadband technology, the broadband capacity everywhere. What we are, in fact, what we are expecting is only the coverage on demand. Whenever we need the coverage, we need the connectivity. If you can provide the signal to us, that will be enough. We don't need you to provide the so-called seamless coverage. So the same thing as the capacity. We are not expecting 1 gigabit everywhere. So we only expect that high volume in very limited time in a very specific location. So if you can provide that on demand, that would be good enough. So that means the future network have to be smart enough. You have to be you have to have the capability to sense the needs of the users, and then to provide the best the appropriate technology and services to them. That is my consideration. But of course, this is a very tough goal. In order to have this kind of intelligence or the smartness, you may need a lot of AI technology. You may need a lot of prediction technology that may also consume energy. So we have to keep the balance. So thank you.
Thank you. So the next one, I would think is related to this coverage on demand. And I think at least in Patrick's chart is mentioned that the sustainability also include has other aspect. It's in Luke's chart as well about the inclusive. So I guess Eric, this is something I think you are very keen on this to to connect the unconnected with some remaining 3 billion people.
Yes, absolutely. And this is a topic that we have been promoting for years. I mean, actually, since the very beginning of the discussions on 5G. The one obvious way of achieving this is to lower the cost of deploying networks, because in many areas, I mean, there can be several reasons why people don't have access to the internet. But one obvious reason is the cost to deploy the networks on the one hand, because then in those areas, the revenue that operators can expect sometimes does not allow to deploy the relevant infrastructure. And for that, one way is to extend the coverage of the base stations, because what costs a lot in the network is the radio size. If you can cover a large area with a lower number of radio sites, then you increase the economic possibility to deploy a network in a certain region. So that's one direction. Another direction is, of course, also the aerial platforms, particularly satellites. There are several plans for that at the moment, including in 3GPP for 5G, for enabling direct access from smartphones to satellites. So that's also a way for providing global coverage. Now I have to say that from our perspective, of course, this is something that we are very interested in, but we have a major question mark on the cost to access this satellite infrastructure, because in the end, of course, the cost needs to be affordable. for the operators on the one hand, and also, of course, also for the end users on the other hand. And we today lack sufficient information on the cost of those satellite approaches to have a clear position, I would say, on the interest to use this. But clearly, inclusion is a major topic, and there are, aside from the pure cost aspect of deploying networks and accessing terminals, there are also other aspects which are very important to consider. One is the fact that several people, they have access to network coverage, they are under coverage, but they cannot just buy a terminal for economic reasons. And for that, there are several operators. Orange have, but other operators also have programs to help those people to have access to a terminal and a lower cost subscription to access the network. And then there is another aspect, which is that some people, they are under network coverage and they have the means to have a terminal and a mobile subscription, but they don't have the knowledge to use a computer or a terminal. And that's the fact, particularly to some elder people in our societies, but that's also the fact of people who cannot read, for instance. That's a very basic issue, but if you cannot read, then it's difficult for you to send an email just because you can't read. And for that, there are also a lot of effort to develop vocal interfaces, for instance, to help those people to access the digital world. So there are many very different dimensions for digital inclusion, and we need to consider all of them.
Luke?
Well, I think that was a very comprehensive answer from Eric, to be honest. I don't disagree with anything that was said. So I think, I mean, Eric, you mentioned the cost of deploying terrestrial sites, of course, is in areas where the return on investment is challenging is certainly one aspect. The other aspect, of course, is many of the areas that we might be wanting to deploy them in don't even have ready access to connectivity or to power. So again, it starts to build a little bit more of a case for looking at the complementary role of non-terrestrial aerial platforms of some kind, whether it's HAPS or low Earth orbit satellites, or even the next generation of geostationary satellites. I think you have to be careful to differentiate between the purpose for which you're trying to put the satellite. It depends on what you're trying to connect it to. Connect it to CPE equipment that's placed on the rooftop of a building or a house, providing fixed line style connectivity is one very valid use case, but that's a very different technology to being able to connect directly to a smartphone, which is something that we've already committed from a Vodafone perspective to providing from the sky through an investment in another company. But I think the other comment I would make on this is again, not to conflate the challenge of digital inclusion with the advent of this thing that we're calling 6G. I think 6G itself doesn't automatically or instantly solve connecting the unconnected. That's nothing to do with the design of the radio interface, if I'm honest. It's economics, and it's having the right climate in place to support that investment and recognize the returns that countries and nations get from having people with access to information and being able to also to provide the connectivity to the machines that can help improve the efficiency of farming or the efficiency of transportation or delivery of healthcare. These are all things that, even to Eric's point, delivered into communities where there is a low literacy level, providing those communities with solutions that allow crop yields to increase because they're automatically measuring the humidity of the soil and automatically providing targeted irrigation. That can also provide huge returns on investment if the country is able to invest in that type of connectivity. But again, I would not necessarily link that to 6G. It's more what we can do as a community to help drive that cause. Now, through that, there might be some things that we haven't been able to address through the the portfolio of technologies we have today, and those will then form the requirement for saying we need something a little bit more special for these particular niches. That's fine as well, but I think we've got a huge challenge that we need to solve right now that we can do using existing tech if we're able to get the climate right. So that would be my thoughts on that.
Thanks, Patrick.
Yeah, it's quite hard to come up with new views. I think, you know, the way you, Eric, and Luke put this, if I'm gonna try to take a slightly different spin on it, it would be, you know, it's about internet for all, and it's about developing the society. And I agree with you when you say that, okay, in this aspects, this is not necessarily a 6G thing. On the other side, if this is about internet for all and developing society, knowing that we are in this now 9-10 year span, there might be particular ways of developing the technology so that it would lend itself easier to sharing, or lend itself easier to enable those additional impacts that gives you the economy, so that you can do this for a certain area. So I agree with you, Eric, that it is about looking at how you can make on one side, how you can target the technology, either for using the mobile technology or going towards the satellites. Both of those need to be into this when we try to solve it. But then again, this is not a technology problem. It's about the global economy and how we choose to evolve our societies. And being a mobile operator, being in some markets where we have got the chance to really make a difference, this is what we do every day, and I think we'll continue to try to help in this direction.
Thanks.
That would be my input.
Thank you, Patrick. Professor New.
Okay. So personally, I don't think the satellite the satellite can solve this problem, because they may not be affordable for those people who have not connected. So normally, satellite communication, no matter is LEO or GEO, they are quite expensive. I don't think they can afford it. So, but in replace, I believe, as I mentioned earlier, the broadcasting infrastructure may play a key role, because the broadcasting infrastructure that has been there for many years, so easy to deploy, and also they can provide the service to a wide area without any handover or something like that, and also in a very low cost. And also there are no congestion. They can serve as many as people without any congestion. So the only problem is the return channel. But normally, if you have a very, something like the GSM or very low data rate network, that would be good enough for return channel, for sending the request, and all the contents will be downloaded from the broadcast. So that will be, I think, a very good format for this kind of question. For this, so in fact, in the year 2008, I wrote a paper published in the IEEE Communication Society that is named the Integrated Communication and Broadcast Network, a new architecture. And I also had a European project, the FP6, so named the MIN-T, together with our European partners to make that new technology happen. So this is my point for this question. Yes.
Yeah, thank you. Very good. I will think there were some 20 minutes left. Let's skip this, the number fifth question. We can do some a spin a different way. One thing, because I take the advantage of the moderator. One thing I would really like to ask one question, for the panelists, is regarding the policy stuff, or the regulatory stuff. How do you see your business if there are some opportunity with this carbon tax? Basically, this sustainability will be somehow regulated and really, bundle with your in the, overall service to the end user. Is this type of a tax is a good thing, or is not a solution for the operator? Patrick? Yeah.
Please go ahead.
Yeah, you go ahead.
So that's a surprise question, but on the other side, it's we are following the evolution on the regulatory side all the way, and if this would enable us as a society to move in the right direction, it would be a good thing. Obviously, in each of the markets, it would need to be balanced, so it's not putting a stop to the whole of the operation. But in general, I think we are in very good dialogues with the regulatories and the regulatory governments to evolve going forward. And I would expect this to be one of the topics that we would look into going forward.
Look,
I guess from my perspective, when it's we're not. I said at the start, we're not driven by tax regulations on these things. We have a very, very clearly stated purpose-led agenda that has at its heart a restatement of the commitment to get to net zero carbon by 2030 for all of the source 1 and 2 aspects, which of course is the energy that the carbon that we generate through burning fossil fuels ourselves on cell sites that are off grid, and also the balance of renewable versus non-renewable mix in terms of the energy that we buy. So the energy that we buy, we've committed, will be 100% anyway by 2030. So we're not being driven by taxes because it's the right thing to do. So I think, and then by 2040, so 10 years after that, we're planning to halve the scope 3, which also includes all of the stuff that's adjacent to our industry, and for example, people charging their cell phones or going to meetings or powering stuff that's actually delivered through our networks, but not direct cost to us. We want to halve that as well. So I think it's useful somehow to have the right tax framework around this, but it's not what's driving us.
Sure, clear. Eric?
Yeah, I would have a similar answer as Luke. Also in Orange, we have taken commitments to reduce our carbon emissions. We have taken the commitment to be net zero by 2040 and to reduce significantly our carbon emissions by 2025 compared to 2015. And I would also take the opportunity to say that in France there is a law that has been passed recently and that will enter into force from January 2022, that mandates the operators to indicate to the customers the CO2 impact of their digital services. So in principle, when from January 2022 in France, when you will use your smartphone, you should get an indicator of how much CO2 your video streaming, for instance, or your YouTube video watching is consuming in terms of CO2. And this is not tax related at all. The idea is to provide an indication to the end user about its own impact on CO2 emission of its consumption of digital services, so that the consumers who are concerned about limiting their emissions, they may want to change some of their behaviors about the consumption of digital services.
Thanks, Professor Liu.
Sorry, I think I have to probably skip this. I'm not the right person to answer this question. Thank you.
That's good. Okay, now I think we can open up for the general question from the audience. Is there any? Oh, I think I saw quite a few things on the. Yeah, there are quite a few questions on the chat box. I'm not monitoring that one because the PowerPoint slides. Shall we pick a few to? So okay, so Marty has one. As we have now here 3 operators in the panel operating in developing developing country, what is the experience from that market domain could you bring to mobile research community investigating communication challenges in 2030? Also, for the remote poor areas, could you each mention one main thing that research community should pay attention to in particular? So this is a Marty from Olu, basically to the 3 operator in the chat box. Eric.
Yes, I think we touched a bit this question in our discussion earlier, but there was one thing that we would like to see is ways to extend the coverage, and we also think in Orange, because we have thought a lot about that since several years, is that we may also compromise on the quality of service, because we think that it's better to have a coverage with reduced capabilities than no coverage at all. And when it comes to, as I said earlier, one way of enabling deploying networks in when the return on investment is challenging for operators is to reduce the number of radio sites. But for that, you need to extend the coverage, and of course, this has a price. And one way to deal with this increase of the coverage can be to reduce the data rate, for instance. There are other ways that can be envisioned. Of course, that's not perfect, but this is one way that also we can help enabling connectivity for the areas which are not connected today. Luke also indicated that we have this issue when it comes to deploying radio sites. In some areas, we have the issue of accessing the power, and often in some areas we have unreliable sources of power. So then that's not really a telecom issue, but it's more about having more efficient batteries in order to be able to store the energy when the energy is available. If you think of some base stations which are powered by solar panels, for instance, so ways of storing the energy so that we can then continue to use the base station at night when there is no sun anymore. But that's not telecom research related. But this is a practical issue that we have also in some areas which make it difficult to provide reliable coverage.
Yeah, thank you. Luke?
Not much to add, really. I think we covered this a little bit earlier with the satellite questions.
I think so, yeah.
coverage is king. It's what Eric said, to be honest. There's no substitute for being able to get service.
Yeah. Patrick?
Yeah, I think I just need to agree on that. That seeing the value of connectivity to a village far out in Bangladesh or in Myanmar, and seeing what that, having that connectivity, even though it could be very, very low bandwidth, seeing the value that have to that society and how it evolves is it for me it gives me more energy to try to find better solution for that. And I think looking at those low cost solution in those areas are one thing we should look into. And yes, also on the energy side, there are of course challenges with stability on the energy, and therefore both new developments within the solar energy and battery are of value, even though it's outside our area.
Still, just to add on that, one thing which is still under our area is to make transmission always more energy efficient, because of course if you have a limited energy budget, but you can reduce the energy cost of your transmission, then you can still extend the life of your battery. So that's one thing which is in our hands.
Yeah, I think that is, we can take probably perhaps one more last question from the audience that posed there. There are a few left. I think there are 3 left, but there's the timer is just for one of them. So what is your take on use of a 6G by AI, even in terms of a network optimization for machine-to-machine communications? Do you think in the future the majority energy consumption will be around this line or by humans? That means, is it the energy consumption is come out from machine-to-machine communication or the human communications? Professor Liu?
Yes, this is a very good question, I think. Definitely, I believe in the future, I mean, in particular for 6G, not 5G, in 6G era, the machine-to-machine type communication will probably dominate the energy consumption of the whole. But in fact, my personal is I'm not expecting that. I hope that will not happen, right? So that will not happen. So this is why I'm proposing we have to use the AI and the machine learning on demand. It's not all the time, not everywhere. So this is my key point.
Patrick?
Yeah, and then I think building on that, I think of course then using the sensors to do the optimization so that you can monitor and control the resource usage and do the optimization is what is key here.
Yeah, Eric?
I think that we have this issue we are very aware of about the need to be sustainable when it comes to communication technology. But I think the same reasoning will apply also for using computing and AI in general, which means that we will also need to make a choice of when using more computing power in terms of what will be the benefit it will bring in the end. So I don't think that we will have enormous computing capabilities everywhere if there is not a strong need for that. And again, I think that the key in the end to enable us to have a more efficient technology, more computing power, more communication capacity and data rates will be to have this a global optimization of the application, the network, the computing platforms, so that we can improve the capabilities that we will deliver while still meeting our energy and material and global environmental impact constraints.
So that the last answer is from Luke.
Yeah, AI, machine learning, I think these are all, this is something that will have a big impact in the way that 6G is born. I'm not talking about the radio interface necessarily, but network optimization, ruthless automation of the entire thing end to end to make sure that we have the ability to deliver the right service to a machine or to a person at the right point in time, at the right cost, and at the lowest possible energy consumption. That will require the systematic application of AI and machine learning. It's also made me think, though, in terms of the blurred boundary between what is a machine and what is a human. If you look at some of the most recent launches of XR goggles and glasses and Ray-Ban doing these things. So if I'm a person and I'm wearing these glasses and it's generating a huge amount of data because of what it thinks I'm looking at and putting that back in to create a virtual world around me, is that human or machine? Because it's me that's instigated it and I'm consuming it. But of course, it's not a human communication. It's from this machine that I've happened to have attached to my eyeballs. So it was just making me smile in terms of there's going to be a lot of blurred boundaries when we look at this in the future, I think.
Right. Excellent. I think we can close the panel. Thank you very much for the panelists, and thank you for the audience. It's very interesting and stimulating. Hope to see you soon.
Thank you, Dr. Tong. Thank you.
Thank you.
Thank you all.
Cheers. Take care.
Okay. Bye.
Thank you.
Thank you very much, Sean.
Bye, everybody.
Take care. Bye-bye.
Bye.
Bye-bye.